this episode of Finno Machining we are going to deal with a rotating platform for my lathe. Well, it has a rotating platform already, the chuck. It rotates. It's a spindle, so it spins. But there are some situations when you want to have a rotating thing in there which you can rotate manually. And this is a tool holder for my a Multifix tool post, which I purchased from PV Tools. Well, it's quite good. What's special about this is the 32mm hole there where you can put a thing which I already machined, this kind of a thing, and you can put it into the hole, and then you of course can tighten it and it stays there. Then you can put this into your tool post. Okay, we have a tube with a hole. Then we have a shaft like that. This is 25mm thick shafting, which has been case hardened. It's stone hard on the outside, but it's soft inside. And then you can put this inside here. My original intention, this is quite tight fit actually. It should be. Yeah. So my original intention was to just put it there and use this as is. But I soon noticed that I realized that that's not a good idea. If you want to spin this fast, it will go actually. So therefore you need some sort of bearings. At this end I will put a bearing like this. It has needle bearings and a thrust bearing. It's a complete package. Goes into there. And furthermore, now I was really lucky. This one is exactly, it's suitable for this shaft. How lucky can you get? Not like that. Okay, that's one end. And obviously the other end needs well, I will put this double row bearing on the other end. Mainly the forces are pushing and seldomly pulling, and one can also avoid that one. Well, the thing is that when I put a bearing at this end, it will be like a weight lift, and of course you cannot put it into this one without dismantling, like hacksawing it first and then put it there. No. I need to do some things at this end. That's the reason why it's a little bit longer. Probably a threaded part, or well, let's see what that will be. I will retain the shaft thickness of 25mm. It's very good. It's like thick enough. And then there will be a plate at this end which you can then rotate, and of course there will be it will be attached to the shaft, and then you have this bearing and handle on this end. A rotating platform that is. And so let's start with the bearing fitting into this one. Well, here is the setup. It's quite simple. So the thing is that we have to bore a recess into this piece which I have now attached to my 4-jaw chuck. Well, this is not with independent jaws. These are self-centering. And this is the original Weiler 4-jaw chuck which came with this lathe in 1972. And but since it is a 4-jaw chuck with self-centering jaws, the uses are somewhat minimal for this one, and it's not versatile. So you can do round objects, but these must be really round. And then you can do square objects, but those must be really square. And same goes with hexagonal, etc. But since their usage is limited, it hasn't been used a lot. And now this amazes me. I just stuck in this piece and then I measured how big of deviation I get, and it's actually, well, yeah, 300ths of a millimeter. So you don't need to believe me, you can also see yourself. Let's put this there so you can really see it. There is the needle. I think you can see it now. I rotate it. I couldn't wish for more. This chuck is wonderful. Well, back in '72 they made quality stuff. So now I will just bore it. This is actually, wait a minute. So now I will just bore it to the depth of this thing. The outer diameter of this is 37 millimeters. So I want to make it a shrink fit. So this will be like 36.95 maybe. And furthermore, the outer diameter of this one is not much more. It only leaves, I measure it here, I should have the measurement, yeah, it's 41 millimeters. So it doesn't leave me much material on the walls. It will be, well, it will be really thin. So it will be something like under 2 millimeters. But it's still enough for this application, because again the forces will be pushing more like twisting. So yeah, let's see, I will now start boring this one. I don't want to bore you with boring. Well, that joke you probably already heard. So, okay, this is now the setup. The first thing I will do is to bore this hole. It's now 25 millimeters plus some change. I will put it a little bit larger, because now we are not relying on that surface with the shaft that's going in, but on the bearings. So I don't need. I want it to be a little bit loose there. Actually, quite a lot loose. So I will take out of the diameter, that is 0.2 millimeters. So I will be using, it will be about 1000 RPM, and the feed rate will be, it's 1 BC, it's 300ths of a millimeter per revolution. And the insert in this case, it's really, it has a very small cutting radius. So the surface finish should be, well, at least very good. So let's see how this goes. Okay, that went well. A little bit of chatter in the backside, but well, the stick out is 12 centimeters. So maybe that's the reason. And I was using my vacuum on the back side of the lathe to suck the chips away from the hole. So therefore there was coming no bird's nest out from that hole. So the next thing is the recess and I actually measured this one, and it's 25.25 millimeters. So it is exactly 0.2 millimeters larger now. Good. So, and this piece of shaft will go there and be very loose. So, but that's not the case here. We need it be done with bearings. So, now I would like to make the recess, and it will be the depth of this this part here. This part which is going down into the hole is 19 millimeters, so we make it 20 millimeters deep. Yeah, and we don't need this kind of stick out here, so we will shorten this. Yeah, this is the boring bar I made to replace this straw, Chinese straw. Yeah, so I have now shortened it. There was really a 14 centimeter stick out, so that's really is this now? Yeah, it is, and a hair more, so we are in the safe side. There must be at least that much of recess. It can be longer, but it cannot be short. This is a hard stop, and this lathe has ability to run against a hard stop. So now I just put it here, and it will stop there each and every time without a feed. You can use this with ordinary feeds. Of course, when you are using the lead screw, no, then it will crash. The lathe, there is a pin that will a fuse pin that will pop out, and you have to dismantle something and do what you need to do to replace that pin. So now our depth is set up, and I can start making this thing. So, okay, now we are at the moment at the inside diameter here is 36.46 and I measured it multiple times from different places, and it's that. And now our goal is 36.90, maybe 7. 5, 7, around that range. It might be even 98, but not over, over 37. 37 is also a little bit suspicious. So 36.96, 97. So I will take it in two passes. First I take 0.2 millimeters, and whatever is left after that I will then take that in the last pass. Now, the result should be 36.96. Let's see. That surprises even me if this succeeds. Let's see, let's measure it. This is exciting. The first step is to ensure it's really clean, and then snap the snap gauge there. Then wiggle it a little bit, tighten it, and then push it over like that. The first measurement tells like that. Hopefully you can see it. Let's take another. It's actually exactly 46.96. This might, oh yeah, this sometimes happens. The snap gauge slips, and again it's slipping. Okay, now it's tight. Let's see, this measurement might be wrong. No, it's not. This is telling me exactly the same measurement. Let's take a third one. Like that. I cannot get anything else but 36.96. When you put the bearing in there, it has to go there in straight, and for this reason I'm going to get 5/100 of a millimeter away from the very beginning here. So let's see. And this I'm going to do just manually. Oh, I cannot. Oh yeah, okay. I need to go back. Let's see. I had exact numbers here, I believe. Yes, I did. Yeah. So, let's take 5/100 of a millimeter away from the very beginning here. Just a tiny amount. So that the bearing starts straight. That's enough, I believe. Now it's easier to put it straight there when you have that kind of thing there. Let's try. It should now go just a little bit there when I put it there. This should now go in. Just a tiny amount. Yes, it starts easily. And after that, yeah, it's easy to start now. Okay, I have put this piece into the chuck, and it's quite straight, at least it's straight enough for our next operation, which is, well, it will go there like that. And now we create a thread into this end. This is now 32 millimeters in diameter. 32, yeah. And I will make M32/1 thread, and the thread relief will be around there. Hopefully that stays. It stays. So now let's see if I can. This is way too fast. If I can mark that one there. That will be our thread relief, and the rest of this will be the thread. So first I will be bluing this one in order to be able to read my scratch pads. So let's blue it with some black. There you are. Not there. Missing something. Okay. Well, and now I will do a chamfer at this end. Let's see how that works for me. This doesn't need to be very large. I believe we are there. Okay. Nice chamfer. And now I will touch the thing. This is probably not totally concentric, so let's see. There you are. It's not concentric, as you could see. So now I reset my dial here at 0. So I'm not using the compound for feeding in. I'm just using the carriage. So next step will be a tiny scratch pass there. And let's see. Well, first I would like to practice how fast does this move. Okay, it doesn't move too fast. And now the tiny scratch pass. Not to that direction, to this direction. Yeah. There you go. Yeah, that was quite a big scratch pass. But let's see how it is. Well, it should be 1 millimeter pitch. Now I'm finding my correct gauge here. These are some width board. Oh, there we have 1 millimeter. I believe that one is 1 millimeter. Okay. And now I just put it here. And look at it. Well, to my book, this is okay. So, now let's do the threading. 1.23 millimeters deep. Then we should be good to go. Let's see how it looks. Okay. First let's put some oil here. Let's take very carefully like that first. That was okay. Then we take, let's take down to 0.5 millimeters. That was really like, okay. Mm-hmm. 2/10 more. There you go. Okay. 1.25. I believe this is the last pass. This is a spring pass for the previous. Oh. And now, since we have that thread should now be ready, but it has a horrific burr on top of this. And now, since we use this kind of method, like I know exactly where the top of the thread is. It's there. That is top of the threads. So I can take 0.05 of a millimeter away from there. So this will actually like that. And then I put the back gear off, and now I should just skim the tops of the threads here. Like this. And now I just skim them very slightly. This will mitigate any burr on top of the threads, and now back as well slowly. Like that. Oh, it feels way better now. We'll put this under there to protect my bed, and take away any burr from there, if there was something left in there. Yep, looks way better. There might be a sharp start for this one. Oh yeah, there is. And now I will also file a wrong direction. And then let's take this corner. There is a sharp corner here. And also that one. It looks nice, doesn't it? Let me zoom you in. Okay, now we will put the bearing into there, and I will use my heat gun, warm this up quite a bit actually. Oh, it's not hot enough yet. Okay, it's well over 100 degrees now. Okay, let's see what happens now. Well, if I'm lucky, it drops in like that. There you are. Now we just wait for a while. You see it's steaming. It's already so tight because when the temperatures equalize, this won't come out. Well, there you are. That's how you put a bearing into. This was so. It was 0.04 of a millimeter too tight, and I believe it was a slip fit now. But of course, it's no more a slip fit. It will be very, very, very tight fit now. So you again need a hydraulic press to get it out from there. So this is how you shrink fit a bearing into something. No glue needed. It's and especially no hydraulic press is needed. You just drop it in. Well, we succeeded in making a very, very good part. This is actually, it looks nice, I would say. The surface finishes are overall really, really nice. And the thread succeeded well, and especially the shrink fit, which is, well, it's easy to do once you know what to do. But I can tell you, you can go wrong with this one easily. For example, if you make the hole too tight, so then it won't go there like that. If you make it too loose, it will never tighten. So then you need to do Loctiting or something like that. So, but that's ready. So, in the next episode of Finno-Ugric Machining, we are going to do the other end here, the one that you screw into here. It also has a bearing in it and so on, yeah. But that will be in the next episode of Finno-Ugric Machining. Till then, see you!